I was having a discussion with a friend and we were talking about what are the fundamental constants, what are the numbers that describe the whole universe? And there's not a one answer. He said there were eight, and I couldn't really agree. We couldn't agree on some things. So, but these are the constants that are pretty fundamental, especially in physics. And then there's some questionable ones. So let's just go over some of the biggest fundamental constants in physics. Number one is the gravitational constant. This is the constant that gives you the gravitational force between two objects with mass. So it's kind of a big deal. It's very small. Next, we have the charge of an electron. Now, I think this one's a constant just because all the other charges that we see, all the other fundamental charges are some value of that, even if it's a fractional value of that. So that is kind of a constant, right? Uh, Important point, the units are kind of arbitrary. We pick these units and then the units for different things matter based on what we picked on the other units. So it can get pretty complicated. Next we have the, I call this is the permittivity of free space. This is the electric constant. This tells you, it's a lot like this for electric charges. What's the force between two objects with electric charge, and that tells you that proportionality constant. And then we have the permeability of free space, and this is the permittivity and permeability. I get those two mixed up. It doesn't really care. It doesn't make sense. And this is the magnetic constant. So this is deals with the magnetic force between moving charges. So right there. Now, some people say, oh, the speed of light, that's important. Well, the speed of light actually is dependent on these two things, right? Because it's an electromagnetic wave, and if that's my electric constant, that's my magnetic constant, I can get the speed of light. So I put it not fundamental. You could technically pick that as fundamental, but then you don't have two of these fundamental because they're all related. They can't be whatever they want. Those are the biggest ones. Now, you have other things like the mass of electron. A lot of people put that down, but there's no like easy way to say this is my fundamental mass and I can find all the other masses. Then we have the fine structure constant. Now that I mean really we never see that in undergraduate physics. We have the Boltzmann constant. I didn't put it as fundamental because it really deals with statistical things about temperature, and that's not really fundamental, I think, but whatever. And the same thing with this Stefan Boltzmann constant. That deals with thermal radiation for temperature for large objects. And then finally, we have the cosmological constant lambda, capital lambda. Again, you're not going to see that in undergraduate physics. That. Definitely you're going to see those.